So my name is Zbigniew Rzepka. I'm a software engineer at Ganymede. And I want to talk to you about Armada and technical aspects of highly available microservices. And you haven't heard about Armada, probably. Wait, no, yeah. OK. You probably haven't heard about Armada, so first I will brief you a little bit what it is. Then we'll look inside the containers, and we'll see how service discovery is being done. Then we'll move to hosts and talk about clustering. And if we talk about clustering, I will mention recovery. How can we recover from different types of failure? OK. And then we'll see what happens actually. How can we combine service discovery with clustering to achieve the ultimate high availability? And it stops working for some reason. I'm sorry. OK. So basically, what is Armada? Armada is open source DevOps tool for microservices. Basically, it's a Docker enhanced with various features designed for microservices, mostly for development, deployment, configuration. Basically, if something works in development, it works in production. We have tools for configuration deployment. If you want to keep your configuration in a private repository, if you want to keep your configuration in a private repository, you can use Armada to inject this configuration inside of your service. And there's management, so stopping, starting, diagnosing containers, stuff like this. There are three main components of Armada. One is HashiCorp Console, which is a distributed services catalog. And we use it to store information about running services. So basically, if a service starts or a container, let's say, is the same thing, it registers itself into console, and then we can do something with it. Then we have HA proxy, which is a high-performance load balancer. We store it in every container with, yeah. And basically, it's used mostly for service discovery and load balancing. We use it to map the service external address, so a host address, into containers, local host address, and specified port. You will see how it works in about 5 minutes, I guess. And then we have supervisor, which executes all the scripts that we run inside of our microservices. So did I skip one? I skipped one. OK, so service discovery and how it works. Basically, as I said, when we start a service or a Docker container, let's say we stick to the rule where one container is a one service. There can be more, actually, but sorry, let's keep it. So every service or every container registers itself into Armada, so into a console distributed catalog. It's done automatically. We don't have to take care of it every time we start a service. And then other containers or other services can discover the service simply by asking console for a name of the service that they need and using HA proxy to bind this service address to a local host address. So let's talk about example. Does it? OK, let's say it. Leaderboard. Let's say we have two services. We have a leaderboard server, which is a simple service which we use to store information about leaderboards. This is actually a real-life example. And then let's say we have a leaderboard panel service, which basically only displays leaderboards and requires the server to provide data to it. So what we do is when we run the server, it simply registers itself in Armada. That's all it does, then it keeps working. And leaderboard panel also registers itself upon running. And then it uses service discovery script to ask console or Armada for a specified host address. And then we bind with HA proxy. This is a supervisor config. It's extremely simple, actually. That's all you need to do to use service discovery with Armada. The first entry is it's a simple run server, right? It's Python 3 server py. And the second one, program require leaderboard server. That's actually where the magic happens. We use require service.py script, which is a service discovery script, to ask Armada to bind leaderboard server to port 2000 inside the container. So if we use this, we never have to worry about running services on different ports. We don't have to remember that some ports might be already used. We don't have to change our configuration. All we do is we specify this require service on port 2000, and we can always use localhost 2000 to connect to the leaderboard server service. And this is how it works. This is how it works. So we have our host. We have leaderboard server, the left one, I guess. All it does is simply registers itself and then keeps running. And then we have a leaderboard panel, which actually registers leaderboard panel. Sorry, it's a copy-paste typo. So what happens here is, first we register to console, as I mentioned. Then we use supervisor to execute this require service.py script, which creates a configuration for service discovery. And then we have an actual service discovery script, which runs every few seconds, I don't know, 10 seconds or so, and discovers the services over and over again. And then with discovered services, we update into proxy configuration to use this pattern I spoke about. The reason we use service discovery script, which runs in every 10 seconds, is because when one of the services drops, stops working, fails, we want to discover them again. We don't want to use a service which doesn't work, so we update our configuration every now and then. So there's a cool thing to it. It's automatic load balancing. So if we have, for example, two server services and we discover them, they are automatically load balanced in a round robin method. So first second, first second. I want to say order. And the service is actually, if one of the servers fails, we stop it or it becomes state critical, some exception, whatever, it's automatically dropped from the load balancer. We don't discover it anymore. It's not there. And when the server is back on, when an exception has stopped, we reopen the service, anything, we can use it again in a load balancing pattern. So we get discovered once again. I mentioned service states. There are actually three of these that we use. There's a passing state where everything works. There's a warning where everything kind of works, but for example, there are too many errors. This is something you have to code on yourself. And there's a critical, which is really straightforward, something doesn't work. Okay. We check the services. Actually, Armada doesn't really know about the services that we run. Every service is, let's say, independent. All it does is every 10 seconds or 10 to 15 seconds more or less, it runs a health check script, or there can be as many as possible, and then it registers its state to console. So if after 10 or 15 seconds, let's say, we don't have any information on whether the service works or not, we assume it doesn't. Let's move on. Kinds of health checks. Well, actually, by default, we check only whether the port 80 inside the container is open. If it is, that's cool. If it's not, well, it's probably a problem. This is default health check because we don't really know what kind of services somebody might want to use. So, but usually you open port 80. So that's kind of a nice default. Okay, let's move to clustering. All right. Okay, so more or less when we have three hosts, this is how it works. We have three hosts. We have Armada or Armada agent installed on all of them. And we can simply connect to them. So if we run the Docker containers or services on any of these hosts, we can see it, we can manage it from any other host. And this is a pretty nice thing. And it's extremely straightforward and simple. This is just one common operation. You simply specify Armada join and then the server name. So it's either your IP address or a host name, Buffalo, or whatever you fancy. And all it does is we simply join console data centers or agents together. And console thus keeps data intact for us. So using Raft consensus algorithm, it's a quorum-based algorithm, we make sure that the data we store in a service catalog is consistent. So every time we run a service and the service registers itself in the console, the data is propagated to all the data centers and it's kept consistent with hosts. We can use one, it works. We can use three, it works because we have a quorum of two. But if we use two and one of them fails, well, obviously we'll never reach quorum. The quorum of two is two. And if one host failed, it keeps working and not working. Is it okay? Okay. Okay, so let's talk about disaster recovery. When we have servers, we can be sure that eventually something will fail, even if we try not to do it. So we try to prevent any damage that a disaster can cause by storing data about running services in two places. We use console, key value store, to store basic cluster info, and also physical files where we store information about running services and an archive. And so we're able to recover from 4 different kinds of failure. There's an Armada failure, which is pretty easy, and I'll just get to it. Armada failure is the simplest thing that can happen. If Armada stops working, everything else keeps working. Even if you have services that you run using Armada, once they're deployed, their configuration is static. It updates every now and then, but if Armada doesn't work, the configuration stops changing simply. And so everything keeps working unless, and when you restart Armada, everything is back on, nothing's screwed up. Docker host failure, this is a little bit tricky one. When Docker, for some reason, decides to shut down, or our entire machine is down, or someone pulled the plug while cleaning, what we do is, when we start up, we automatically rejoin the cluster. So then again, that's why we can't really have 2 hosts, can never reach the quorum. But we rejoin the cluster, preferably of 3 or 5 hosts. And then we restore all the running services on this host, on this Armada, from runtime info file. This is one of the files I've mentioned that we're storing. And even if there's a disk failure and Armada is unable to recover from the file, that's why we still keep data about the running services in console key value store. Yeah, and manual screw-ups are something we can't really protect anyone against, but we have an archive of services which have been running at a given hour. So if you accidentally screw something up, shut down a service, and you don't remember which one was it happened actually, you can recover them manually from a file, and everything keeps working. And if you specify a file that you want to recover from, let's say, let's recover everything from, I don't know, 12 a.m., only the services which are no longer running right now and were running at 12 a.m. will be recovered. So we don't shut down anything that you have started ever since. And okay, and I was supposed to talk about high availability. I talk about everything, but not that, pretty much. So let's move back to it. Now that I've mentioned clustering, I've mentioned service discovery, let's see how to combine it. And we combine it in pretty, it's quite simple way. Let's say we have 2 hosts. Okay. Let's say we have 2 hosts. It's 10.0.0.1, 10.0.0.2, and again our leaderboard example. We have a panel server, and every, let's say, 10 seconds or so, leaderboard panel asks Armada agent for the leaderboard server address. It gets 2 leaderboard servers, it load balances between them, and everyone is happy. But if something happens to one of the servers, if they stop working for some reason, whether they're just down or their state is critical, it doesn't really matter, they no longer send any health check to Armada. So within, I don't know, about 10 seconds or 5 seconds, they are removed from from Armada. The Armada registers that something is not okay, something's wrong, and the next time leaderboard panel asks service discovery script actually asks Armada agent for a leaderboard server, it only gets one, because the second one, even though it's running, probably it's in a critical state, so there's something just wrong with it, and we don't want to load balance with not how do you call it, not okay service. And eventually, when we recover from anything that could have happened, the help track is back on. It registers the leaderboard server, registers itself back into Armada agent, and everyone is happy together. As I said, Armada agents are basically console agents. So even if the recovered service informs only one of the agents, they synchronize data between them, so it doesn't really matter on which host do we run the panel, and we'll always get two addresses now that we have, again, two services. And that's pretty much it. You can try it out. Actually, I'd like to encourage you to try Armada. It's really simple to use, and it's fun to use. I really like it. That's why I came here to talk about it. We have a ready Vagrant image. You can just type Vagrant up, and you have a VirtualBox ready for development. And unlike Kubernetes, you don't need free virtual machines to test anything. And you can just use Armada create my service to check it out. And that's pretty much all. You can visit our website, armada.sh. You can visit our GitHub repository. And if you check it out now, before you ask why is there a private key in the repository, it has to be there. And also, you can visit our company website if you like poker games or Pool Life Pro. So, great, that's it. Thank you. And if you have any questions, feel free to ask them now. I forgot to include my email, I'm sorry, or anything, actually. But feel free to ask them now, later, at the after party, and when I'm drunk. So thank you.
Thank you. We have a few more minutes for questions. If you have any questions about Armada.
Come on, don't be shy.
Okay.
Hello, thanks for your speech. I would like to ask if Armada does contain something like monitoring tools where we could track this synchronization process of agents, for example.
Armada itself, no, not really. Although from what I know, console provides a visual interface for data centers, but we haven't really used it, and Armada is purely command line, and we never had the need to track it. It usually just works. So,
but what if it's not working?
It's a problem.
How do you handle those situations? How do you monitor it? How do you track its log files and so on?
Well, one thing is we have a log file for Armada. So if something happens inside the Armada container and it's still running, or whatever happens to it, we can still use, for example, even Docker exec to enter the container, check the logs, what went wrong with it, and pretty much it always works. We've been using it for over a year now in production environment, and we never had an issue where we have a cluster of about 10 hosts, and we never had an issue where entering the container, checking the logs wasn't enough. We never really felt the need to include any visual or any monitoring, actually, for that kind of thing. We have a diagnostic methods for containers, but for Armada itself, logs are fine.
May I have another question? Does Armada help you somehow with wiring containers with data-only containers, for example?
Say what?
Does Armada help you somehow with wiring containers with data containers? Because it's a very common pattern to have data of containers in data-only containers. Does Armada helps you with wiring those two things?
if by, it's the first time I heard this term, I'm sorry, if by data-only containers you mean something like Redis, or for example, like a Redis service?
Like a container which stores only data for a container. Because we want to keep containers stateless, so we basically try to move this data somewhere else, for example, to data-only containers. Mm-hmm. And I was wondering if Armada has something like a built-in support for that helps you wearing those things.
We've never used such a thing. Well, we only keep our data in either MySQL or Redis. We have a Armada Ready service with Redis, and all it helps is you can use actually service discovery to always connect to it. But we don't have anything specially for that. So kind of, yeah, I guess.
Okay, thank you.